the initially it's all just basic imports that we have, unzipping the dataset and all. Then we have this dataset verification check, dataset integrity check. And what it does is basically, here we are just splitting the dataset into 3 parts, and then we are labeling it, and we are just building the path to the basic the configuration file, and then we construct the part2 images and label directories, and this is how we do it. Then the next part of the code is analyzing keypoint visibility. So it just loads the libraries for plotting and data manipulation first, and then it defines one class, which is pitch, and the number of key points per object. Then we prepare to collect the visibility stats per dataset split, and we iterate over each split. If the label folder is missing, then we skip it. Then we initialize the counters for key point and visibility flags. And after this, we open each .txt file and read all the annotations. We parse each label here and check for format validity. And we verify the class ID is within the bounds or not. We validate the number of key point values. They match the expected count or not here. And then we convert it into float and parse the visibility flags. 0 for not labeled, 1 for labeled but not visible, 2 for labeled and visible, and so on. Then we count the visibility key points only that have valid coordinates, and we handle the non-numeric value errors and update the image count. Then we add the visibility stats to summary dictionary, and what we do is then we just print the visibility analysis for each split. Then we plot a bar chart of visible key point counts across dataset splits. As you can see, here is the bar graph. Okay, when we move to the next part, it's basically visualizing ground truth key points. First is the basic importing of tools for image loading and randomness. Then we collect the training images and define the color for boxes like this. Then we pick up to 3 random training images to visualize here, and we load the images and get the dimensions. Then we find the corresponding label for the image, and we parse the bounding box detail and append them here. Then we parse the key points as triplets like here, and then we prepare the image for drawing. We convert the normalized bounding box to pixel coordinates and draws the bounding box and class label. Then we plot each visible key point with a marker and a label and display the saved and visualized result. As you can see, this is the ground truth values that we obtain, which is like the accurate values. Then we move to the next part, which is visualizing augmented samples. So it is focused on visualizing the effects of data augmentation on both bounding boxes and key points in the dataset, annotated in the YOLO format. So first we just apply the color based augmentations with full probability, and then we just randomly sample images. Then we load and parse the annotations here, and for each sampled image we load the corresponding YOLO format label. We extract the class ID, the B box and the key points. Then there's the application of augmentation, which transforms image, bounding boxes and key points. Then the visualization part starts, which is creating a subplot with left augmented image and right we'll have original image. Applying clip, and then at last we are just debugging and logging the results. Then the next section is for like YOLO V11 based pose estimation model using Ultralytics package here. And here's the background of like what is happening. So it is basically loading the YOLO V11 pose model pre-trained weights as a base model, and then we are like launching the training process with specific configurations described here. This is the training over like 100 epochs. These are the graphs that we obtain after the training part, and these are the ground truth values, and these are the predicted values. This is just a part of like seeing the like debugging, and here we can see the actual result that we obtain, where at one point we'll have ground truth values and at one point we'll have the predicted values. Explaining the graphs in a little detail. So basically these are, where can I find the graphs? So basically these are like training loss curves, validation loss curves, and bounding box metrics that we obtain. So we can see that general trend that all the training losses show a smooth downward trend over the epochs, and in the validation loss curves, losses initially spike in the first few epochs and then it goes down.